So what session is this that you've wandered into? Migrating an OLAP workload using stored procedures to achieve faster performance with lower costs. My name is Chris Goldston. I'm a lead solution architect with AT&T. I've been with them for grand total about 15 years now. Been designing and building and working on data analytical applications for them for internal customers. The application that we're going to talk about today is one that's coming up on about 13 years old, give or take. It's called My Results, and I'm one of the 3 original architects of that, and I've re-architected it a few times over the years as the needs have changed and technologies have changed and requirements and so forth. But that's a little about me. Sean, you want to say a few words?
Yeah, I'm Sean Ramsey. I am a migration architect at Snowflake. I've been with the company just a little over 2 years. Spent most of my time doing migrations here with this AT&T migration. Prior to that, I was at Disney and did several migrations between SQL Server to Netezza, and Netezza to Snowflake, and we actually retired the system that I stood up, 15 years earlier. So that's kind of my background. Brought on to help this team migrate the application, which to me, when it first was presented to me, I'm going, this is not a standard migration, because the focus was the application and not the ETL or, a Cognos reporting tool or something on top. So that really sparked my interest in actually engaging with this project as opposed to another one. So I'll let Chris take over.
All right. Thanks, Sean. Also, Sean's also an all-around great guy. He didn't put that in his bio, but you should put it on LinkedIn or something. Okay. Just all-around great guy. All right, so today we're going to talk about our story of our migration for our app. We're going to begin with a pretty detailed application overview. I think it's important to hopefully give you some context and maybe color around why we felt our application was going to be a little bit of an atypical use case for Snowflake, which is why we had to do a proof of concept with Snowflake to make sure that it was even going to work. So we're going to talk about what came out of that proof of concept, and then Sean's going to spend a good deal of time on the actual migration, digging into the technical details of the solutions that we came up with. Like any battle plan, they say, doesn't survive first contact with the enemy. It's kind of how our migration went as well. Once we began the actual work, we discovered some of the things we had planned to do, they weren't going to quite work out the way that we thought. And then finally, we will talk about the stuff that we've discovered since we've been in Snowflake now. We've been exclusively Snowflake for our application for just shy of a year. So we discovered some things immediately after the migration and some additional discoveries as we've gone along, and it's provided us with a bit of a roadmap for the future as well. So our application was the result of a business request really to simplify. Many years ago, we had a very robust, very solid data warehouse built on Teradata, everything optimized for Teradata, to give reporting to the AT&T retail stores, field users, as well as the management structure. I should say singular at the time. It was before AT&T purchased them, but they did their reporting primarily through a BI tool, and it was primarily business objects at the time. They came to us and they said, this is expensive. We're paying a lot per seat licenses for this. So we have a whole group of users that they don't need all that horsepower for business objects. They just need something simple. We just need a dashboard on a web page that has 10 or 12 metrics on it. Can you build that for us? And then they can go about their daily activities. And once they see that, and we want to pay for licenses for them. So that's what we did. And it grew. It really, really grew. So from where we were, this is where we are today. We had about 10 or 12 metrics initially for that first dashboard. Today we have a library that's over 2,700 metrics spanning multiple subject areas, no longer just the AT&T retail store information. Our screens have greatly expanded from just having one dashboard. We now have over 80 different custom screens, all of which are driven by user-selected options, which will allow them to filter the data that they want to query. Some of those screens now, just a few of them mentioned here. We've got things like historical trending. It's a very popular one. You can track order life cycles, ranking, real-time sales. One of my favorites is the customer survey results. that was kind of fun. We have some very articulate customers when it comes to providing comments on the user experience. And the mean ones are really quite funny too. Our user base, as I said, has expanded. It's no longer just company-owned retail. It's also authorized retail. We have call centers now, and we'll get into a little bit about the user base here in just a second. Also, some of these screens, I will be giving you some actual production screenshots so that you can get a little more context around those too. We found that our users love data grids. Now, that may not be universal to your situation or your applications, but we offer them charts and graphs, and they can configure them, pick what they want, export them to PowerPoint, do these things. But they really love data grids. They just do. And I think it may have something to do with that last point there, is that most of our data sets across the application can be exported to PDF or Excel. We have a certain class of user, and you may have experienced this, that will go into the screen, select data, export it to Excel, do their own pivot tables, send it to their management and say, look at all this amazing original content that I just created. So, all right, let's see. Let's take a look at some of the user stats. As I said, our user base has grown dramatically from where it was originally, which brought on a whole host of concurrency issues and things like that. It spans all these different groups that you see up there now. It's about 115,000 credentialed users for the application when I put this together. It's been as high as 130, so there's some fluctuation there. I'm not sure if we were doing surplusing back in March or not, but who knows, that could have taken a hit on the user count. But out of those users, 100,000 of them are actually active in using the application each month. So we're pretty proud of that. That means that if you have access to use our application, chances are you are using it. And on any given day, we will have about 35,000 users actively using the application, primarily between the hours of about 8 a.m. and 8 p.m. They tend to follow the retail store hours as well as call center business hours, but not exclusively. It's available 24/7, but that tends to be primarily when the activity is happening. The way that our application is set up is not terribly uncommon on the back end. We do a full ETL build out of all these different metrics and a few other data sets so that we can pre-populate some presentation ready tables that the screens will be selecting and returning to the user. We store all of that in the application database. We have a JavaScript front end that's custom that we own as well, and that is where the user will interact with the screen that they're on. They have some different selection criteria and filtering criteria, more on some screens, less on others, but those will be used as named parameters that will then be passed into an API call to the database. For the Teradata experience, before we migrated, it was all Teradata macro calls. The database then responds to that query, returns the data set, which is populated on the screen. Now, we could talk about our whole ETL migration process too. It's not really the subject for today, but it came with its own host of de-optimizing it for Teradata challenges as well. Everything in our application was built in a Teradata ecosystem that was completely optimized in every possible way for performance on the Teradata platform. The users of our application, they can use tablet to access it. It's very common if you go into one of our stores, which hopefully you all do, and purchase a great many products and services. You'll see them holding a tablet, and that has several applications, one of which will be ours, and they're probably using it. Other users may use their mobile device, and the rest of them are using a traditional desktop. The place we really want to focus our talk today is on these API calls. So I mentioned earlier that we have 35,000 users, give or take, that are actively making requests to the database between 8 a.m. and 8 p.m., more or less. And that generates a lot of concurrency because we have over 1 million API calls a day. That number is actually a little bit higher. It's probably like 1.1, 1.2 million calls that are being against the database every day. And our business requirement is that when they make that request, that data comes back from the database in less than a second. So about 90% of the time, that's exactly what we deliver. The APIs that we use to manage our application, we've got a bunch. We've got about 230 plus. Now, obviously, they're not all equally used, they're not all as equally popular. They're tied to different screens and so forth. So the usage can vary amongst them, but it takes about 230 to completely do what we do. And again, all of those APIs, well, almost all of those APIs are parameterized and getting back filtered data sets. Now, I should say, this is about where we reached out, and once we began the migration, we engaged with the Snowflake migration team, and they sent us Sean. So I want to give Sean a second. When you came in, this was the environment you walked into. What kind of thoughts did you have when you first saw it?
Yeah, like I said earlier, that this was something that interests me because I came from Disney prior to this, and I worked with the guys that did all the front-end API stuff for logins and registrations and so forth, so if you go to that platform. So I felt comfortable in this space, right? That was one of the interesting things. But some of the other things that I noticed, especially as Chris will get into when he kind of shows some of the screens, is there seemed to be a lot of interaction that would happen, or potential interaction, that would look like it would repeat the query again and again, right? And that was one of the things that we noticed. And some of the other stuff was that because of the dynamic nature of the parameters in these macros, the result sets that could be returned could be widely different, right? From a shape perspective, meaning the number of rows could be 10 to millions, right? Or the number of columns could be, 5 or 10, in some cases 20 or 30, right? For the same query, right? So you can see from that nature of the way things were working that this was going to be a very dynamic set of SQL, where even the SQL statements themselves are dynamically changing as the queries get passed to them.
So enough talking about it. I thought we'd go ahead and show you some screen samples. I got 3 different screens that are actually production screens that we pulled. Legal did have us wash out the KPI names and the metric names, so they're a series of dots now. You won't be able to take any competitive information away from it. Same with the organizational names. But the second most popular screen that we have in our application is what we would call historical analysis or historical trending. In this screen, the users have so many selection options, they have a selection screen before they actually go and request the data. The first thing that they will select if they come into this is, what organization level do I want to see my metric totals at? If they're a store manager, they may want to see location. If they're, say, a market VP or something, they may want to see the market level totals. They can select what kind of targets they want to see that are associated with the metrics. And at AT&T, we have several types of targets. Might be the same at your experience as well. So they pick one or none if they want. We offer them, 5 different time frames that they can choose from. And within each of those time frames, they can then select a data range so they don't have to get the entire range. There's a few more check boxes for different types of columns and attributes that can be returned. And then they select the metrics. They can add to the list, and we try to do a little help for the user because 2,700 metrics is an awful lot to sift through. So for each user that logs in and they come to this screen, there's some back-end work that will, via API call, that will limit the metrics to just the ones that are relevant to them. They can search for it by a name or an ID or even the group that it might fall within. Well, they finally have done all that. If this is something that they do pretty frequently, like say every day they come in and they go and they want to select the metrics, they can save it so that they don't have to do it every single time. They can save their selections. They hit grid it and they go. And like I said, they will get this screen that has this, beautiful graph on there, and they can change the type of graph and export it to PowerPoint. And they usually don't look at that. They look at the bottom. They'll look at the KPIs. What were the actual values they had? What were the targets for that time period? How well did I attain towards my target? And that's the data set that they'll really be most interested in. I like this next screen, it's ranking, because I think it gives a nice competitive view of things. It's also driven by configuration. The business will decide what are the metrics that are most important that we want to measure our performers by, and then how much do we weight each of those metrics. So when this data set's produced, it's all produced via configuration. The top part of that screen will show an individual, how do I rank against my peers? in each of these groups? How do I rank against my peers nationally or within my market and so forth? The bottom grid will then show how their direct reports rank against one another. So they're able to then find some opportunities where maybe they need to coach the people that they work for, get them to focus on different areas and so forth. But the most popular screen by far is this one right here. We call it whiteboard because it was born from an original whiteboard in the store locations. They would take a marker, go back their daily huddles in the store, it would create a whiteboard thing, and it had this information on it. They were doing it manually, so we built it for them. It's called Team Drill Downs now. It's got, and we have options where it's grouped by subject areas. So if they want to focus on mobility metrics or fiber metrics or customer satisfaction, those things, they've got all, they can go to that specific one. But as you can see, this tells quite a story in one screen. That top box, you can't tell because we've put dots in the name, but that top block would be the person who's wanting to see what their own totals are. And then all the blocks underneath them would be for the direct report level that they want to see their details as well. And it tells them, how am I doing? How much of this thing have I sold this month? What's my goal for this month? How well am I attaining toward it? How did I do last month? And of course, the most important one is, what do I need to sell? So that's the application in a nutshell. We didn't give you all the screens because we'd be here all day, but this is where we went into the proof of concept with Snowflake to say, hey, can you guys actually do what we do today?
Okay. Yeah, I came in after the POC was done. I actually didn't start with Snowflake till after the POC was done. But I do have some overview I can give you. Initially, when the POC was executed, they took a set of about 10 of those top procedures that are macros that you guys, and I'll use those interchangeably, sorry, those top macros that they had, and basically decided to take those, break those down, bring those tables into Snowflake, and then basically execute these as UDTFs, which was about the equivalent we had for a macro, and execute those in JMeter, right? And from that, they came up with an initial architecture that, if we look at it, looks something like this, right? Where the web application tier would spin up its connection pools, right? The web application would then initially, when they initially did the projection, basically would pin a warehouse to a user-defined table function. So basically that would kind of force the application to say, I'm going to run on this warehouse. And they were doing that primarily for warehouse caching, right? So basically, if this procedure is using this table, or this macro is using this table, this UDTF is using this table, we can get as much of that into warehouse cache as possible, so that as people are hitting it, we're not, reloading from storage all the time. Initially, this was projected out to use one store procedure to one UDTF, which at the time there was roughly 200 plus user-defined table functions. So when we started looking at that, that was probably not the best option. From a cost perspective, that's awful costly. So it was later revised a bit to basically say, okay, we're going to group them together by procedures that are using, or UDTFs that are using the same tables, right? So that's kind of where we ended up at. And if you look at this, there was a couple of things that were a challenge, right? So if you walk through this, you start with a web application, it's got its connection pools, it's using the connections. It would have to switch between them. And then what would happen is that these UDTFs like I said, would only use warehouse cache. And so that's kind of how that piece of the architecture worked. After that, a couple revisions, they came up with some costing, right? What they projected the cost to be based on those 10 store procedures and associated testing. Then coming out of the POC, there was a couple challenges we ran into. Well, there's a couple things we really liked, and then there's a couple challenges we ran into. The thing we really liked was the idea of pinning the execution of a warehouse or the execution of a procedure to a specific warehouse where needed, right? And then grouping those together, because that gave you, like I said, the warehouse caching came into play at that point in time. But there was a couple things that it wouldn't necessarily work for us. or we thought there might be a better idea. So as I said, user-defined table functions will not use results cache. So we saw in the case when I looked at the way the procedures execute or where the macros executed, you could see that there was a potential for someone to navigate away from something and then back into something and then navigate away from it, which would then result in executions happening. So I had a hunch that there was some of that going on. It requires extensive recoding on the front end side, right? Because one of the things we're trying to do is lift and shift this as much as possible. So the front end, we wanted to impact that as least as possible. So the idea of having to have the front end pin the warehouses and switch warehouses and do all that extra work was something we kind of wanted to avoid. And then several other things. Portion of the Teradata code actually did multiple SQL statements in it, which we couldn't do in a UDTF easily, or within a SQL UDTF, should I say, easily. A couple other things came into play. Again, as Chris was saying, based on the way these things are called, there's a lot of default and optional parameters to these. So that was kind of a challenge that we, with the way that Snowflake overloads to do that, that was going to be a problem when you have 20 or 30 parameters and 10 of those are optional, or 5 of those are optional, or 15 of those are optional. So we had to address that too, and there was no simple way to do that. And of course, as Chris pointed out, 13 years of working on it, there was some very creative SQL optimizations specifically for Teradata. So this is the architecture we ended up with. We decided to go from user-defined table functions to stored procedures, but that had its impact, right? Stored procedures don't allow us to return a result set, right? We can only return a single row back, right? So we came up with this architecture where it was a 2-call architecture, right? So the first call would be to the stored procedure, and then a second call, based on what was returned from the stored procedure, the application tier would make a secondary call to get the result set back. And in doing that, we also did a couple things. The application tier itself is tied to a set of warehouses that it will query to by default. So it only has to worry about setting up the connection pool to 2 different warehouses that are multi-cluster warehouses. And then inside the stored procedures themselves, they would actually go in and change the warehouse if it was mapped into tables. So we wanted to create a dynamic environment so that as we were moving through and releasing, because this was going to be a complete cutover all at once, we wanted to be able to tune as quickly as possible, and having this type of architecture allowed us to do that. And then what happens in there, in that primary call, right, to the stored procedure, when the stored procedure executes, if it doesn't map, it will just leave it at the warehouse and do the front end warehouse. And then, like I said, the secondary call will be made, and then the result sets return from that. We use JSON as the mechanism. We used variant columns for the input and output, which provided us some benefit also that comes into play when we look at the code. And that's kind of the next place we're going to go. I've got a sample of the template procedure we used. We used Snowflake SnowConvert to convert the macro SQL code, which would convert it to a JavaScript stored procedure. And then we actually cut and pasted the SQL out of that into the template that we put together. So I'm going to walk you through the template next. I just talked about that. So those are some of the details. One of the things we also wanted to do, just to note here, is we wanted to make sure that we tagged all the SQL calls so that we knew what was executing, right? We had some idea of what was executing, and they were doing some web analytics tagging with it, and we could get some stuff out of Teradata, but we wanted to make sure that we knew exactly what those parameters were, because those parameters make the SQL that gets executed so different in behavior that we wanted to make sure that those were also included. So that was one of the things we did. So as I walk through the code, yeah, this is JavaScript stored procedures. At the time, that was about all that was available. And quite honestly, I'm not sure that we could do this in a SQL stored procedure, what we've done here, or at least as easily done it in SQL stored procedure. So if I look at it, again, like I said, a single variant comes in that has the parameters that we want. It comes in as a string, or comes in as a variant. It's passed and compiled as a string. it returns a variant, which the variant has in there the query ID. That is the last query that gets executed as part of the store procedure. It also has a SQL statement that gets passed back to the application tier, and they then, that's the query that they actually execute. It also lets them know if it was successful or failed, so that they can deal with that error message if it failed, obviously. And then also too, we had a situation where there were calls that return data, and there were other calls that updated data. So basically, this was something we put in there that is there a second call required, right? So basically, this allowed the application, when they built their libraries, to say, okay, I can easily build this library and know that the first call, if I don't get something saying it's secondary calls required, that means I've done what I need to do. That's just building the return object. And then basically we go through and set the default parameters. So like I said, there's a lot of conditions where 5 parameters would be required, especially on some of like the whiteboard and so forth. There would just be a few parameters required, and there'd be 20 parameters available, right? So this logic would allow us to go in and set those default parameters so that when we go bind them later on, that they're covered. We go in there, and the first thing we do is we set the query tag, because we want to make sure that everything that executing in that store procedure is tagged to that the procedure name and the parameters that were passed to it. And then basically, we determine what the warehouse it should be mapped to, and set the warehouse. Again, like I said, that's done conditionally. And it's configurable, right? So basically, if we needed, and we didn't know, we may have needed 2 more warehouses created to kind of optimize the load, we wanted to be able to dynamically do that. So basically create the thing, do the mapping, populate a row on the table, and have that procedure running somewhere else. The query, that's the query, just a simple query, and just through the rest of it, right? Through the building the SQL for the secondary call that gets passed back, and then handling the errors, and then switching the warehouse back, and we're done, right? So, it's a fairly simple template, but there was a lot of value in having that template, right? And we'll come to that piece now. So coming out of there, like I said, we did a cutover. It was a go, no go. We cut over, and if we cut back, it was going to be a while before we could cut over again. So we wanted to fail forward, right? We wanted to fail forward as much as possible. So as part of the process of the tagging, we had all this robust information available within the query history within Snowflake. So I started out by building a set of dashboards that I thought at the time, when we were looking at the load testing and stuff we were doing, would be beneficial for us to have as we start releasing those 100,000 plus users on the system that we just put together, right? And so one of the first things we discovered, which was kind of a shock to, I think, most all of us, because we didn't have the information, is that over half the queries that were executed were queries that were the same query, right? It's just someone navigating away from a screen and back in, or maybe someone going into the same screen later on in the day. So basically, since this data is loaded daily, that results cache, right? So that all of a sudden now we got results cache happening. It's not even using the warehouse. It's just coming back with that results cache, which, was really kind of one of the first things that happened, that we just like, wow, this is not what we expected. And then we had another discovery, which we should have anticipated, but what's quite interesting is data refresh puts a sudden load on the system, right? And this is a graph of that. This is a daily graph, and as Chris said, starts at 8 in the morning, right? And so this was what we noticed here is the spikes that are coming in as soon as those last refreshes of the data are happening, and all those results caches are invalidated, right? So that's what we started seeing. We started seeing this sudden spike. And this is how it looks from a query perspective. This next one is how it looked from a session perspective, right? So basically what we noted was all of a sudden the web server was now going to spin up additional clusters because it was waiting longer times for the results to come back, and there's users hitting the query, right? And when data was delayed, it became more of a challenge, right? Because some of our first breaks in the application tier happened when we were late on one of the data loads. There was people in there refreshing the screen, hitting the refresh button, waiting for that data to be hit, and it was queuing up, and we'd see these huge spikes as part of that, which, at that point in time, we were able to start tuning things, right? Let's put another multi-warehouse cluster. Let's start with two warehouses in the cluster and so forth to kind of, remediate that load, because that was something that they determined they wanted to reduce that spike level and reduce those times that people were waiting. And this is the problem procedure that we did. This was the whiteboard. And as you can see, this little spiky there is when the data was refreshed and it was late and people were pressing the buttons, right? And basically what happened is the upper bounds was the primary call, and the second one was the downward is the secondary call, right? So as I told you, there's a primary call that happens by the application server, and then there's a secondary call that happens by the application server once the results are set. So you see this big spike of everything queuing up, and then once the data sets were refreshed, you see this big spike downward, which would be all the results coming back, right? So that's kind of one of the issues. And what we also had where our timeouts were not set at the application level high enough, and they would start timing out and also adding to the problem by killing connections, right? So we are killing the queries. And so you'd see this pile up. Stuff we worked for, like I said, it was a fail-forward situation. We did not want to roll back at that point in time. There'd been too much work done and too much to try to roll it back. So post-migration. I'll let Chris talk about this. I mean, there was a couple things that I recommended as I was leaving, since I was a migration consultant. The migration was done. I left them with, some ideas of things that they could do to do things post-migration. Some of it happened before I was off the contract, and some of it happened after. So I'll let Chris kind of talk about those a bit, especially the stuff after I left.
So we found that, as I told you before, we were highly optimized for the Teradata architecture. We found that there were a lot of things that worked really, really well in Teradata, had the opposite effect in Snowflake. And we have examples of that both from our stored procedures as well as the ETL. And it was a prominent problem. We couldn't fix it all at once. So we've been doing it little by little, taking the biggest chunks first. But what we found that was great about Snowflake is in our optimization efforts for Teradata, it kind of handcuffed us as to what we could do. There were re-architecture desires on some of these high-impact screens. We couldn't do anything about it because we had architected the table structures and everything else for single AMP performance, and it was all about data retrieval, but that made ETL loads a little bit longer and harder. We were able to do away with all that, and in the last several months, I've made some changes to the architecture of the heaviest hitters that we had to fix that. We've also been able to take the pool of virtual warehouses that we were using and pinning the stored procedures to. Now that we've had a lot of data points to look at, we found that we could consolidate and collapse a lot of those. And by re-architecting, we were even able to downsize some of the ones that were pinned to those heavier use procedures. I don't think legal would allow me to say the actual numbers, so I'll try to give them to you in a way that gives some context. When we came out of the POC, Snowflake estimated our annual run rate for our application at what to me was a really high number. So let's just buy the business objects licenses. This is crazy. But it was a big number. We were all in. We went in it anyway. And when we were running for a few months, we were able to look at what are the actual numbers looking like because of results caching, because as we migrated, we were able to do some optimization in some areas. We were running at 1/6 of the costs that they thought we would be running at. And then with these additional changes that we've made in the last several months, we have shaved another 35% off of that lower number in addition. Well, thank you all for coming.